All right, let's begin. We are starting in Unit 4. This is our first lesson titled Learning Targets, Proportions, and Similar Polygons. So this whole unit will be learning how to prove that polygons and triangles are similar as opposed to congruent. So we're going to start off reviewing proportions. Proportion shows you the correct way to pronounce it. Proportion is an equation stating two ratios are equal, meaning two ratios being two numbers compared to each other. So essentially we have two fractions equal to each other. And the only way it is truly a proportion is if the two fractions are equivalent to each other. Okay, so we see that 2 over 3 is equal to 8/12. And if you were to reduce 8/12, that would indeed reduce down to 2/3. I could divide both of these by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So that shows me it is a proportion. I can also see 5 over 10 reduces to 1/2. Divided by 5. So yes, those are proportions. All right, so what we're going to be doing is reviewing how to write ratios and then reviewing how to solve proportions. That's the start of this lesson. Okay, so let's write a ratio together. The problem is a bonsai tree, which is this little itty bitty tree, is 18 inches wide and stands 2 feet tall. We need to write the ratio of the width of the bonsai to its height. Now, if you notice in the initial problem, be careful here because our two measures of unit are not the same. I'm measuring inches and feet. In order to compare them, I have to have them in equivalent units. So what I can do is I can convert either this one to feet or this one to inches. Looking ahead, though, I see that they do tell me I have to put them in inches. So the bonsai is 18 inches wide, which I'm pulling from up there, and it is 24 inches tall. Okay, because 12 inches in 1 foot, so that means there's 24 inches in 2 feet. So those are the numbers we're working with. So we can write a ratio two different ways. We can write it with the words 2 in between, 18 to 24. We can write it as a fraction, 18 over 24. We can also write it with a colon, which are these little dots. Okay, so those are just 3 different ways to represent ratios. Most commonly, you'll probably see it with a fraction as a fraction, but just be aware that the others do exist. All right, so let's go ahead and solve it now. So here's our proportion. 9 over 2 is equal to A over 14. We need to figure out what A is. So there's a couple of different methods that you can use. Okay, we could figure out, I'm going to show you one method. We could say what times 2 is equal to 14? Well, 2 times 7. So then I can multiply my 9 by 7. All right, and I would get 63. Okay, so that's one method, but you may start to notice that as our proportions get more involved, meaning I have multiple terms up top, okay, this number doesn't evenly, 2 maybe doesn't go into this number, maybe this number was 15, it doesn't go in evenly. As things start to get more complicated, I need another solution that will work easily for any problem. So if you think back to your Algebra 1 and middle school days, to solve a proportion, we cross multiply. Draw butterfly wings, as I like to say. Okay, so I cross multiply. So I have 2 times A, which is just 2 times A for right now, is equal to 9 times 14. So now I'm just solving this equation. 9 times 14 is 126. And then I can divide both sides by 2. And so we get 63 that way. Okay, so cross multiplying to solve our proportions will help us drastically, especially as we start to get more involved ones. All right, we will be doing lots of practice with this in class. So if you have a question, please bring it to class and you'll get a chance to practice. All right, we are going to also learn how to write equivalent proportions. So the problem says use the proportion x over 6 equals y over 7. What ratio completes the equivalent proportion? Okay, so it's saying what is going to go in the boxes here. Now notice we're not solving, we have 2 different variables, we don't know what they are, that's okay. We're writing an equivalent proportion, meaning they're equal to each other. Okay, so let's take a look. It says circle the proportion that is equivalent to A over B is equal to C over D. So what I can do is I can flip both of these. So if I flip this first one, B over A, I have to flip my second one. So the same variables are still next to each other. Okay, B is still next to D and A is still next to C. Okay, which would be this first example right here. That's the equivalent one. So I can do the same thing for this problem. So I flipped x over 6. I flipped it to 6 over x. So I'm going to flip this second ratio as well. And they are in equivalent form, okay? So as long as I flip both, it is okay. All right, let's take a look at this problem. I want you to pause the video and go ahead and see if you can figure out what is wrong with this proportion at the right. How did the person solve it incorrectly? Then solve it correctly on your own. When you press play, the answer will be up. Okay, in the error, the person did not cross multiply to solve. They multiplied the denominators and they multiplied the numerators, which is not going to help us. So here you can see the correct method, cross multiplying 7 times x equals to 4 times 3, which is 12. Then I divide by 7 and I get 12 over 7, or 1 5/7. Okay? All right, so proportions. Cross multiply to solve. Let's take a look at the next concept that we're going to talk about. What we're going to start talking about is similar polygons. What makes polygons similar as opposed to congruent, and what we are going to do with this. All right, so pardon me. What I want you to first take a look is this box up here that I'm drawing an arrow to. That is the sign for similar. Okay, we've seen that this is congruent, an equal sign of that little tilde over it, which you've also seen in Spanish if you've taken it. Similar is just that little guy. Okay, so we are going to be looking at that, showing polygons are similar. So things that are similar are alike but not identical. All right, well, what does that mean? Okay, well, one thing to think about is when things were congruent, everything was the same. The angles were equal measure. The sides were equal measure. That's made something congruent. When we talk similarity, we're going to be talking not as involved as that. All right, similar polygons are figures that have the same shape, but not necessarily the same size. Okay, so the same shape, but not necessarily the same size. So we're going to look at what has to happen in order for them to be similar as opposed to congruent, or even just neither. Okay, so here it tells us 2 polygons are similar polygons if corresponding angles, meaning in different diagrams are in the same location, if they are congruent, and if the lengths of the sides, of the corresponding sides, are proportional. Okay, so that's why we started with proportions. They are similar if the angles are congruent and the sides are proportional. Okay, so the difference between congruence and similar: congruence, both angles and sides are congruent. Here the angles are congruent and the corresponding sides are proportional. Let's take a look and see what that means. All right, so we're looking at polygon ABCD and polygon GHIJ. So the directions say draw a line from each angle in column A to its corresponding angle in column B. So we're just going to match corresponding parts. So let's take a look. What angle corresponds with A? Well, it's G. It's the first letter in the next name. I can also tell by looking at it, and they kind of gave me those markings. I have the red right angles. So this one is similar to this one. All right, B. Well, looking at it, the second one, B and H, and I can tell by my diagram, B and H. They are corresponding, meaning they're in the same location in both polygons. C. Okay, so I've got C and I. Take a look over here. It's marked for me, C and I. They both have one angle marking, so they are corresponding. And then D and J are last. D and J. And over here, too, they both have the double angle mark in my drawing. So those are our corresponding parts. Okay, A corresponds to G, B with H, C with I, and D with J. Okay, so now let's talk about the corresponding sides. So AB, I'm going to erase my angle markings to get a better picture. AB corresponds with GH. And we've kind of already talked about this, guys, in previous units. Even looking at the letters of the name, looking at the order they go in. So AB and GH are right next to each other. So AB over GH. So up top here, I'm going to have all of the sides from my first polygon. Down below, I have all the sides from my second polygon. So keeping them together. So AB over GH, we're saying is going to be equal to BC over HI, going in order. You can also look at the order of the name, BC, HI. All right, something over IJ. Well, here's IJ. Its corresponding side is CD. It's going between those two angles. We already said we're congruent. And then the last one, AD with GJ. Okay, so those are the corresponding sides. And if you notice, under my markings on your paper, you see equal signs in between. Because we're not saying the numbers have to be the same, but we're saying when you reduce them, they have to be the same. That makes them proportional. All right, so let's actually look at an example and look at some numbers. So problem number 1 says understanding similarity. Polygon DEFG is similar to HJKL. So what are the pairs of congruent angles? What is the extended proportion for the ratios of the lengths of corresponding sides? What? Okay, all we're doing here is once again naming like we did above. Okay, here are the 2 names of the polygons. So go ahead, identify the corresponding angles, and identify the missing sides or the corresponding proportional sides. I'm going to pause the video, try it on your own. All right, take a look. Here are corresponding angles over here. Okay, that's supposed to be a J. All right, and then the proportional sides over there. So that's what I mean by complete the extended proportions, just writing the proportions of all the corresponding sides. Okay, we didn't have a diagram to look at, but I looked at the order that the problem was named in. Okay, now let's talk numbers. Sorry about that. All right, so determining if they are similar. Okay, are the polygons similar? If they are, write a similarity statement and give the scale factor. We'll talk about what scale factor means in just 1 second. Okay, so problem number 13 says circle the short sides of each rectangle. Underline the long sides. So looking at it, we'll look at KLMN first. The short sides seem to be KL, so it says circle the short sides, and NM, or has as MN. Okay, the short sides of the other one are, let's see here. Careful, look at the numbers. XY and WZ. CW. Okay, the long sides are KN, NK, and LM. And then in the other one, they are the W. Oops, sorry, I was supposed to underline those. Roop, roop. Okay, so just identifying which one's short and long. Remember, you may have to look at the way that the picture is displayed. It may be turned. If you notice, this one is turned. It's turned sideways, okay? All right, so write the ratios of the corresponding sides in simplest form. So they're giving me the sides to look at. I'm going to start by reducing. Simplest form, reduce. So take a look here, KL over XY. So I've got KL over XY. Okay, those are corresponding parts. All right, because I'm looking at KLMN and I'm looking at XYZW. XYZW. All right, those are my corresponding parts. So KL over XY, 10 over 15, I can divide them both by 2. And I'm left with, I'm sorry, by 5, and I'm left with 2 over 3. LM over YZ. Well, LM is 15. Okay, I see that right here. Y, if this side's 15, this side's 15. If that side's 10, that side's 10. Properties of a rectangle. 20 and 20, 15 and 15. Okay, so LM is 15 and YZ is 20. So I'm going to reduce those. So I can divide both of those by 5. And I get 5 over 5. 5 by 5 is 3. 20 divided by 5 is 4. All right, MN is 10. CW is 15. And when I reduce them, I get 2 over 3. Okay, and then I get NK over WX. NK is 15. WX is 20. Those reduced to 3/4. Okay, so what we just figured out here were the scale factors. Scale factor means taking the corresponding parts and simplifying them. Okay, and that ratio that comes out is called the scale factor. Now, in order for this to be, these two polygons to be similar, the scale factor has to be the same across the board. These reduced fractions have to be the same. Looking at them, are they all the same? No, they are not. Okay, yes, I have pairs of them, but they all have to be the same. They all have to reduce to either 2/3 or 3/4 or whatever the number may be. Okay, so in order for two polygons to be similar, all the corresponding sides need to reduce to the same number, so that scale factor has to be the same across the board. And then also we said all angles have to be congruent. Well, looking at it, I know they are because they're all right angles. So that one works out. But the sides are not proportional to each other. Okay, the scale factor is not the same. So, yes, the scale factor for this guy was 2/3. Yes, this was 3/4. And yes, they are not similar. The corresponding sides are not proportional. Okay, and putting in parentheses also scale factor. That's what we mean by our scale factor, though, that number that it reduces to. Okay, so because that's not the case, they are not similar. All right, if they all reduce to 2/3 or 3/4, like I said, then they would be, and you'd be good to go. Okay, let's take another look. Same thing. We're going to look at trapezoids. Trapezoids is a four-sided figure. We won't get too in depth with that. So ABCD is similar to EFGD. We're told they're similar. Okay. So we're saying what's the value of y? So we have to find out what y is equal to. We will get there. Okay. One step at a time. So it says circle the side of ABCD that corresponds to EF. Here's EF. Its corresponding side is AB. Okay. Because look, EF in the beginning, AB. It says use the justifications at the right to find the value of y. All right, so corresponding sides of similar polygons are proportional. Well, that's true. So EF is to what as ED is to AD? So EF is to what as ED is to AD? Well, we already put that. It's AB is the answer. Okay, so those are the corresponding sides. So we're going to use that to help us. We don't need all the information. We just need our corresponding sides there. Okay, so we're going to substitute our values in. EF is y. That's the length of it. AB is 5. I see that number right there. ED is 6. And then AD is 9. So to solve this, I will cross multiply. 9 times y equals 5 times 6, which is 30. So therefore, y equals 3 1/3. Okay, or 30 over 9, 3 1/3. All right, so I'm using similar polygons to help me solve problems. All right, guys, remember, we are going to do lots of practice in class, so bring your questions. We just need to know how things are similar. We'll practice looking at examples, deciding if they're similar. Then we're going to start solving problems. Okay. We have 2 more problems to look at. So a rectangular poster's design is 6 inches high by 10 inches wide. Okay, what are the dimensions of the largest complete poster that will fit in a space of 3 feet high by 4 feet wide? Okay, so here's my poster, 6 by 10. Okay, I want to know what is the biggest poster that's in this proportion, so meaning it's similar. Okay, I'm not just going to make it 3 feet by 4 feet. It has to be similar. So how it's going to fit in there. So first, let's figure out what changing our height 2 inches, or feet 2 inches. 3 feet will be 36 inches, okay, because 3 times 12. If I divide that by 6, I can see how many posters can be in there. So if I have 36 inches total to work with, I have 6 inches. And 6-inch poster, I divide it, I get 6. Okay, 4 feet is 48 inches. When I divide that by 10, I get 4.8. So I don't have a whole number. Okay, so I need to figure out the most times that the design can be enlarged by. Okay, so how many times can the picture fit in there most? Well, I can fit it height-wise 6 times, and I can fit it width-wise 4.8. Okay, well, it has to be the same number for both in order to fit the picture in, because we can't change its scale. All right, so thinking about that, the most number of times I can fit is 4. Okay, why 4? Well, I can't have a chunk of it, or I have to keep it to scale. So I have to look at my smaller number, okay, and find the whole number closest to that without going over, which is 4. All right, so the most times I can fit in is 4. Let's skip number 19 for right now. All right, so if I want to figure out the height or figure out the dimensions, so if it's fitting 4 times and it was 6 inches to begin with, 4 times 6 is 24 inches. The width is 10 inches to begin with. 4 times 10 is 40 inches. Okay, so we're going to stop the video there. I want you to try number 5 on your own and bring it into class. It's kind of tying everything together. Looking at proportions, thinking about that scale factor, and whatnot. So today what you should be able to do is solve proportions by cross multiplying. Know how to identify if polygons are similar. All the corresponding angles have to be congruent, and all the corresponding angles corresponding sides have to be proportional, meaning their scale factor is the same. We will work in class on how to find that scale factor more.